Greetings, the Astro 30 here yet again, and today I've got this Aaron powered subwoofer. Its model is Sub-240, and it's got a problem, and the problem is it has distorted sound, and I can verify that it's got distorted sound as we were testing it last night, and then all of a sudden it had absolutely no sound. So it's either now completely died, or it has some form of auto off function when it can't detect the audio signal. So the first thing I'm going to do is, before I do anything, is I'm going to put it on the dim bulb, and I'm just going to verify that there's like no DC coming off of the output here on these fly leads, and then see if there is any sound coming out of it still. And then I will pull it apart and we'll have a look together. I have just noticed one thing. These crimps are so nasty that the actual wire is moving around inside the crimp. It's not actually a solid connection there. The positive one's exactly the same, so I might have to address that as well. So even though it was safe to plug into the wall yesterday, and when the sound disappeared, I don't trust it now, so I've got it on the dim bulb. So we'll just have a look at what happens. I did hear a relay click, and immediately I can see there's about 4 odd millivolts on the output there, which is not bad. So if I turn it off and then turn it back on, yeah, 20 millivolts is not, well, 2 millivolts is not too bad, so it's got a good DC offset. So it is safe to hook up to a speaker of some description. Alright, so I got the thing hooked up to a speaker on the floor. I've got to watch that these leads don't short. It's probably no short circuit protection. And I've got the computer hooked up to it, playing a 70 Hz tone into the input. So we'll just see what happens. Right, well, I can hear the tone, but it is distorted. So let me kill that. So we'll listen to a normal audio track through it, and oh yeah, it's distorting. So, alright, there's no point playing that anymore. So now I need to open it up and find out why it is distorting. So I'll just turn him off and crack it open. So here's a look inside. It's a pretty old school PCB design. It's all through-hole components, which is nice. It makes it a little bit easier to probe around in, and it just uses what looks like standard dual op amps here. This is the power amplifier board. Here's the speaker output. It's a discrete design, and it's just one transistor per rail in push-pull configuration. So I don't expect this to push any more than, you know, 50 or 60 watts. A big EL core transformer here. Other than that, I can't see anything physical with this, although actually I can. Around this resistor here, it looks like on the board itself is a bit charred. So yeah, there's been a bit of heat stress there. However, other than that, I can't see anything else. And there's a little trim pot down there next to that 5-watt resistor in the frame there. That's the bias pot, which is a real bastard to get to. Anyway, the first thing I'm going to do is I'm going to inject a signal into it and leave the output disconnected. And I'm going to just signal trace through this filter board here to see where the sound goes funny, if any. I really should do a supply rail check just to make sure we've got both the plus and minus 15 volt rail, because it sounds like with that type of distortion that one of the rails may be missing on an op amp. So yeah, the first course of action is I'm going to measure pins 8 and 4 of these op amps, although I better look up the part number of the op amp just to make sure they are dual op amps. Well, I checked the supply rails. Yeah, they are dual op amps and they are getting 29 volts between pins 4 and 8. At the start they weren't, and all of a sudden they are now getting voltage. So okay, I'm going to go back to my first idea of signal tracing. Alright, so this is not going to be too easy to signal trace because of the fact it's very low frequency. Okay. Well, it's much louder there, so that's the first stage. It's coming out of there nice and loud. Nothing there. Whoops. Alright. Nothing there. Nothing there. Nothing there that I can hear anyway. Yeah, this is very hard to do. Okay, so signal tracing didn't prove much except that we've got a very loud signal coming off of the pin 1 of the first op amp nearest the connector. I did manage to find the schematic online to it, and I found that the white wire coming off of this connector here back into this one is the output from the input board to the power amp's input. So I'm probing that output or input with my oscilloscope, and we're going to see like what sort of signal quality we've got on the scope. So, well, I can see right away we've got a signal. So it looks relatively clean. It's just not very powerful because I've got the gain down, but it's noisy as hell too. But it's 104 Hertz, which is what's going in, and it looks relatively clean apart from the artifacts we've got there on the signal, which I'm not sure where they're coming from. It could be just random noise the probe's picking up. So I'll just vary the frequency, and as we can see, the filter is doing what it's supposed to do. I've got the pot on the front set to around about 60 Hertz or lower at the crossover frequency, so yeah, it's well, it's doing something. So let's try going up in frequency. And we can see there's hardly anything at 330 Hertz, but there's still all that noise there. Yeah, so I don't know where that noise is coming from. So that does prove one thing, that there's nothing wrong with this input board. The input board is filtering and amplifying the signal as it should and passing it off onto the power amplifier. So the problem with the distortion must be in the power amplifier. So what I'd have to do is I'd have to hook this up to a dummy load, inject the signal directly into the power amp, which might prove a little bit more challenging than it looks, and just see what the output looks like. So I've got some stuff connected. I've disconnected the connector to the input board. I've got this resistor soldered to the pin where the white wire goes, so that's the input to the power amp. That's coming off of my little oscillator down here, just for convenience. And the output's going across an 8 ohm dummy load. So with any luck, we should see a signal. We do. However, it looks like absolute crap. So, okay, what? It doesn't look very good at all. Yeah, that's pretty crap looking. So, alright, let me take it off the dim bulb and plug it in directly and see if we get a difference. Alright, we're off the dim bulb. Yeah, that looks terrible. That is the most interesting waveform I have ever seen. Look at how it's clipping on the top. I am just wondering if I'm overdriving the input here. Let me just go through the resistor that I've got connected, which is 47k. Yeah, marginal improvement. I might be exceeding the input range of the input sensitivity of the power amp. Alright, so I've now got the input signal going through a pot, and yeah, as we can see, it's still distorted. It's clipping early, asymmetrically by the looks of things. So the issue's in the power amplifier board, and I'm not 100% sure at the moment why. Now, if I configure this so it's in ×10 mode, yeah, we're getting like 9 odd volt out, and oh, it looks alright there. Maybe my oscillator was clipping. That looks like it's going down. Yeah, I've got the well, that was an invalid test, wasn't it? This little oscillator is not the best. However, I've got the volume or amplitude set to where it just starts to clip. And the thing is, well, the sine wave looks clean, apart from the fact it looks more sawtooth than it does sine wave. That's only because of the oscillator. But we've got this notch here around about the 0 line. It looks like we're suffering from crossover distortion. That could be a biasing issue. Although I can't really get to the bias pot because it's behind the input board. But this is running on the full line voltage, by the way. We can see that there is a notch there, which is quite severe. So yeah, we've got a little bit of crossover distortion going on, which would not be helping the sound output much. But it's the power output that doesn't look right. It's like 15.3 volt peak to peak, or 6.6 RMS, so that's only like about 10 watts or something. But yeah, that crossover distortion is not going to be helpful. And because it had a crack behind the sound to it, that it is indicative of a sound of crossover distortion, is what I'm trying to say. But that is pretty severe. Yeah, so that's one thing I'm going to have to look at, and that's most likely a biasing issue. So the thing I would have to do though is I'll unscrew this input board and get it out of the way completely, just so I can get to the power amp board. I might remove the power amplifier board. I'll go through and check a few basic components like, you know, resistors and stuff, and the solder joints, and then put it back in. And with the input board removed, I can then get to the little pot. Better turn that off because that's still live. I can get to the little trim pot that's right buried down at the bottom of the board here, and tweak it whilst looking at the oscilloscope output. As for why there's not much power output, well, yeah, that's another issue. Alright, with the input board removed and the power amplifier board just propped up out of the way, looking at the underside, from what I can tell so far, I've measured a couple of capacitors. I've measured the 10 microfarad input capacitor, which is C120 in this case, but it says on the schematic C110, which is and C112, which is part of the negative feedback and gain set path of the AC feedback, AC gain, whatever you want to call it, of the power amplifier. Now to the long tail pair. Now the 100 microfarad at 16 volt, which the value of voltage seems a little bit low considering our supply rails are plus minus 47 volts roughly. It's measuring in at 80 microfarad. It's a little bit out of tolerance. And the 10 microfarad is measuring at 8 microfarad. So I might replace those two capacitors for a start. They're cheap. Now we've also got a bunch of ugly looking joints. This one up here in particular, I believe, is the dropping resistor for the relay drive circuitry. And yeah, the solder joints are ugly. And I can't see anything obvious except around this connector up here. One of the joints is not complete, but that just goes off to the LED display board at the front, or the back in this case. I've tested other components in the circuitry too, some resistors and most of the transistors. They all seem to be functioning fine, so there's no issue there. Well, if the transistors were bad, then well, we'd have no output at all. That's where it is so far, and there is a bunch of circuit glue around on the other side of these filter caps, which is starting to turn brown. So it might be in my best interest to actually take the filter capacitors out of the PCB and clean all that circuit glue crap up and resolder them back in. So that's what I'm going to be getting on with now, is just doing some, well, I'm going to call it preventative maintenance first, and then see if that improves the issue. Because at plus minus 47 volt rails, we should be getting more than 20 volt peak to peak out before clipping. So that's where I'm going now. So I'll get to doing that, and we'll come back when I've actually achieved something. Well, I've got the main filter caps out, and you can see what the circuit glue has done to the PCB surface. It's gone all black. So I don't know if that's become conductive or not. It wasn't around any of the pins or anything, but it also appeared wet when I was pulling the glue off, and I was wondering if the capacitors were actually physically leaking. Although I cannot see any wetness around the capacitors. One may have been slightly wet, but I don't know where that's come from. I'm not sure if these capacitors are like leaking, but it doesn't physically look like they are. But what that circuit glue has actually physically done to the PCB is nasty. Although that's where two of the caps are, and I'm wondering if that is actually leaked. So I've taken the capacitors out in order, so I started with the bottom two. They were the front two that you just saw, and the last two I just took out of the back two sitting on the desk. So I might actually leave those two out for now and test it just with the two capacitors. They're 4700 microfarads, so just two of them should be fine. So I'll get to cleaning up this PCB as best as I can, solder some joints, change those two capacitors I was talking about over the other side, and I think I'll leave these two capacitors out, because yeah, it is damp there, so kind of a concern. Well, the PCB is back in, however I haven't made much difference. The power is still limited to 20 volt peak to peak mark. However, it's clipping at the top quicker than it is clipping at the bottom. So, but the crossover distortion is still there. Well, I've done some further investigation off camera, and I've tested components at component level like resistors. Nothing's open. There's a couple of 22 microfarad capacitors in the DC detection circuit, which is only showing me about 6 to 8 microfarad respectively between the two, which is a little low. However, I was testing the transistors, and I'm pretty sure I already tested the one that's in the center of the frame. This TO126 device, which is a 2SD something NPN transistor, well, it appears to be open base to emitter, but it's fine base to collector. That could be a problem, because that's one of the drivers. That's the driver for the positive going cycle output transistor, and that would explain why it's clipping early and why it's distorting, because it's not driving the output transistor. Alright, so you can look at the multimeter, and I'll just test this base to collector, so it's positive base, negative collector. If I can get the leads on there, that'd be nice. As we can see, from base to collector we've got a junction. However, from base to emitter, nothing. It's completely dead. So collector to emitter, we appear to have some form of voltage drop there, and then it disappears. If I reverse the probes around, looks like we get a diode junction, but there is nothing between base and emitter in either polarity. I reckon that transistor is dead. It's worse than that, it's dead, Jim! Anyway, I'm going to remove the transistor and test it out of circuit. I don't think I'm going to get any different results. And then, if it is dead, I've got to find a substitute. Alright, I've got the transistor out of circuit, so if we test it out of circuit, base to collector. Hello? There we go. Base to collector, it's got a diode junction, I hope you can see the meter. And to emitter, there is nothing. This transistor is dead. Right, so now I need to find a substitute for that. And it's a 2SD659A by the looks of things. Correction, it's a 2SD669A. And according to the data sheet, the collector emitter voltage is 160, collector to base voltage is 180, and emitter to base voltage is 5, and 1.5 amps of collector current. So I don't have any other transistors in TO126. I do have an MJE1532G. I think that's a 250 volt collector to emitter. It's just the only thing is it's TO220, so the emitter and base pins are switched around, so it has to go in the reverse direction in the circuit. Collector is still in the middle. So as I've got a spare one of these, I might as well pop it in. I mean, it's not complementary to the other one, but you know, what can I lose? The base emitter voltage of the MJE is 250 volts DC, and collector to emitter is 250. Current is 8 amps, so it's perfectly within its margin. Okay, the new transistor is in the correct way around and is functioning. I've also put the other two large filter capacitors in there because I can't see them physically leaking, and I have actually tested them on a capacitance meter, and they're coming in at around about 4100, 4200, somewhere around there microfarad. So yeah, it's close enough. So I'm ready to test it, and of course I'm going to do it on the dim bulb because I've made a change. Alright, I've got everything set up now. This is either going to work or it's going to blow up. Either way. So I've got the multimeter connected across the output leads to measure any DC offset if there is any. Input is disconnected, unloaded. Power switch is on the unit. Nothing unusual. And we've got about 8 millivolts of DC on the output, which is good. Dim bulb glow is good. Alright, let's hook this up to the oscilloscope and see if we've actually got a signal. Alright, moment of truth, contact. Oh, we have a signal. That's nice. Haha. 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 There is no crossover distortion. It's clipping early because of the dim bulb. Oh, that's awesome. So there we go, a bad transistor. Alright, let me take it off the dim bulb now. I'm pretty sure it's going to be okay to operate off the dim bulb, and we'll just see how much power we can get out of it. I'm still going through this 47k resistor just to drop the level a little bit, but that's okay. Alright, we're off the dim bulb now, so I'm filming the PCB and see if anything explodes. So I need to turn the power switch on carefully. Nice. We have a signal output. And yeah, this is probably not the best oscillator to do this with. I'll figure that out in a minute. Transistor is not getting hot. So currently we're in times 1. So in times 10, before it clips, we're getting, yeah, only about 9 volt RMS. Okay, I think I'm going to have to try a different oscillator here. Okay, let's try it with the inbuilt oscillator. Oh. I'm going directly into the input. So that's a little bit better. We're getting about 20 volt RMS out before clipping. That's at 1 kilohertz. It's a little bit oscillating at that frequency, but we're getting 16.9. Yeah, that's average, I guess. I'll drop down to the lower frequencies. Yeah, we're getting about 23.5 volt RMS out before clipping, with a little bit of ringing, which okay is 69 watts RMS, so that's plenty to really power a driver, especially in the subsonic frequencies. So yeah, I'm happy with that figure. So we'll ballpark it at around 60 watts. So I'm going to soak test the amplifier for about 5 minutes just to make sure nothing's overheating, and I'm only pushing 12.4 volt RMS, so that's about half power, which is enough to heat things up. And I can feel on the bracket here that, yeah, those output transistors are starting to get warm. The driver itself is starting to get on the warm side. It probably wouldn't hurt to slap a small heatsink on that. As for the other driver, yeah, that's getting a bit warm too. They really should have put heat sinks on them. 5 minutes later, disaster has struck. Unfortunately, it's still amplifying a signal at 13.1 volt RMS. Yeah, fooled you. That's good. That bracket's getting quite warm to the touch. That transistor is pretty warm, so it's not overly hot or anything. Other driver, if I can get there. Yeah, that's getting warm too. They really need heat sinks, so I might do that as a preventative measure. That's probably what took out the original transistor in the first place, is too much heat. And considering it's got a plastic cover over it and it's sitting in a speaker cabinet, well, it's got nowhere else for the heat really to go. Except if it's a ported box, well, then it can go out the port, but some subwoofers aren't ported. Anyhow, I can actually kill that now, because I'm quite happy with the fact that it's operating. I did put a dob of heatsink transfer compound on the VBE multiplier transistor, just so it was getting, you know, good heat transfer into the transistor rather than just leaning it up against the surface. I replaced one of the seal pads on this side because it was ripped around the screw hole, and I didn't want it coming into contact with this because this will ground. And yeah, so that's what I've done there. I really should check the bias now that I've messed with that pot, and Then I can hook an input signal up to it, remove my resistor, test it, and then address these sodding things. Right, so first things first, let me get a couple of little TO220 heat sinks on these transistors. Heat sinks are on. That was a bit of a bugger to do too, especially the other transistor that's just under the filter cap there. I just had the board back out to do it, but that's perfectly fine. So I guess the next thing to do is to put the filter board back in and clean the chassis up a bit and inject a signal into it and see how it sounds. I forgot to mention that this PCB smells like burnt carbon, especially around the two filter caps I had removed. I reckon that's because of the circuit glue has turned conductive and acidic or corrosive, and this is that cheap Bakelite PCB that they used to use, and that's probably most likely why it smells. Alright, let me get to reassembling things. Okay, I got everything back together apart from the plastic shell. I've got it hooked up to the speaker on the floor. I've addressed these crimp cables. I didn't have any crimps the same size, so I just basically soldered the wire and then heat shrinked it over the top of it just to make it look a lot neater than it was. And it doesn't have like wires just like hanging out of the crimp. It's just badly crimped. So if I turn this around and turn it on, came on. No unusual noise coming out of the speaker. So I'll play a track, Emotional Mess, and here we go. Hang on, I don't think I've got enough gain on my... No, I don't. Shit. That was protecting, bringing the protector in now. There we go. Well, I wouldn't say it was thumping bass. Okay, that's enough of the track. I mean, it is working. I wouldn't call it thumping bass, but then that's the wrong type of speaker for this job anyway. So let me go to an online tone generator, and I will just play with a frequency sweep and trip over everything on the room. Protection kicked in. Well, it does certainly have enough gain. Okay, cool. What I'm going to do is I'm going to leave it sitting there idle for a few minutes and see if it goes back into standby, because there is a standby LED here, and you know, just see if it comes back out of standby so I can 100% be sure that the thing is actually repaired. So that PCB stinks. About 5 minutes later it's going to standby. So if I play a signal again, I might drop the volume down so it's not going to come blasting out at me. It should come out of standby. There it goes. Neat. And there we are then, all back together, and I've just tested it before off camera. It's still working fine, which is excellent. I ended up replacing these 22 microfarad 50 volt capacitors that I mentioned earlier, because one measured in a whopping 8.6 microfarad and the other one at 12.3, which is a little low, so they're a bit out of tolerance. And they're in the DC protect circuitry, which it does have. I don't know if I mentioned that in the beginning, but yeah, so they go in series with each other, so it forms an 11 microfarad non-polarized capacitor. And at the different values there, we're going to get probably closer to 7 microfarad, which is a little bit low, and that's probably the reason why the DC protector was operating prematurely. Anyhow, I'm going to leave this one here. I'm glad it's fixed, and yeah, I'll ship it off back to the guy. If you like this video, please remember to go down below, like, comment and subscribe if you haven't done so already, and I will catch you in the next one. Thanks for watching, guys. Have a nice day.